Hey YouTube, are you with me? So, quadratic functions to explore. Today, our session is dedicated to graphing and plotting the quadratic function graphs. Alright, so we'll start from the simple one, y equals x squared. That's not a complete form of the quadratic equation, because you know that complete form for that is simply x squared plus bx plus c. And in this case, we only be using ax squared and leading coefficient a be equal to 1. So all others simply be zeros. All right, now let's go back and have a little history about what sort of graph first we want to explore, how it looks like, and actually go back to ancient time and come back right now to nowadays. So we'll just explore parabolas. Parabolas, that's what is called a graph. Alright, so this word comes from the ancient Greeks, and that's because of the surround objects. So that word comes from the surround objects because it will have a parabolic curve. So ancient Greeks actually, when they used to throw objects, they used to call this track a parabolic curve. Okay, so now if you go to nowadays, you can probably see that, let's say, parabolic mirrors, parabolic antennae like aerials, they made in the form of parabola. Why? So for example, I can demonstrate, and here is the good example of why I will be using parabolas in real life and what sort of application they might have. So let's consider a signal from satellite. Let's say satellite is somewhere here, pretty far distance from the antennae. They're trying to catch and trap the signal, and the receiver actually is situated in a specific point. It's in focus, and signal coming from satellite, it looks like a parallel lines that go into their parabolic surface. All right, so what happened next? So this signal reflected back and bounced off the parabolic boundary of the surface of our aerial, and all beams, or all parallel beams from signal from satellite, they are concentrated in one single point, what is called focus. And here exactly we'll set up the receiver, actually receiver of the signal. Why? So the primary goal is to make your parabolic surface for antennae or for aerial to concentrate the signal and make more, efficient receiving of the signal, because sometimes might be like bad signal from satellites, but if you concentrate the signal and probably from different satellites, you'll have more proper, intensity of the signal, and hence you'll have more qualitative images on your, let's say, TV tuner, right, on the screen of your TVs. So in this case, you simply concentrate in one single point. And this focus is specific for parabola. So each parabola has its own focus. So basically the distance between the focus to the vertex of the parabola is a specific feature of a given parabola. So it means for y equals x squared, is going to be, the focus is going to be like on the specific distance, while for y equals 2x squared, it will have a different or distinct distance. So the foci will be actually on different distances. All right, so we just understand that focus of a parabola is a key feature of this shape. But now we are going to go to abstract math, and we'll be trying to plot the graphs. All right, so we have y equals x squared, and this is the simplest quadratic function that we are going to explore. And how we can do that? So simply, we need to set up the table. Just remember what you've known before from general functions theory, is that y-axis is output, right? While your function f taken in input. So simply in our case, an input is x. So we just highlight that x is simply input. It goes into a specific function rule, and then it's squared up for the simplest function, and then how we can get the output value. So for this purpose, we just simply design the table for x and y values. So we have x value, and we are going to calculate y value as well. So let's say we have your x running through -3, -2, -1, 0, and then it's running through positive numbers, so basically mirrored, all right, up to 3. So the main for our function, we restricted from -3 to 3, and then we are just going to calculate y values using our function rule. All right, so the function rule tells you that you need to take an input x and square it up. All right, so let's square it up. -3 will get 9. So -2 is 4, -1 squared is 1, 0 squared is 0, and what's obvious for positive numbers will get the same square. So basically it repeats but mirrored, 1, 4, and 9. So it means that for this simplest graph, values for y will be symmetrically reflected around 0. So it means that around vertical x you'll have symmetrical value for y's. All right, so let's set up those points on the Cartesian plane. So basically, in order how to plot, you've recently created the table of values, right? That table of values, and now you're just going to drop all those points on the Cartesian plane. So we start doing the right hand side. So basically in the first quadrant, I mean here, when x and y values are positive, so I just limit myself to that case and simply I reflect back. All right, so 0, 0, that's initial point, and obviously it's vertex. Then it's 1, 1, so it's here. Then for x equals 2, it's already 4. So you see, in comparison with straight line that goes simply like that, your quadratic function, your quadratic values are, so tends to increase faster, steeper. All right, so for 3, we'll get 9, and 9 is here. All right, so that's how the graph will look like, and just choose another color. Instead of red, I just put blue one, and let smoothly trying to connect all those points. So probably it's not so smooth because I'm just doing on my phone. So here, that what actually you need to have instead of your right branch. All right, so that's your parabola branch. It's right branch, it goes this way through the points. So one more time, let's circle the points that we've got. And what about left hand side? So obviously you need to mirror that, because for all negative values and the same values absolutely, like 1, -1, -2, -3, you'll get the same y set. So simply I can just repeat all those values in a mirrored way. So actually 2 units here, okay, and 3 units. Okay, so now I also can connect that, so that makes sure you have very symmetrical image. So the right branch actually need to be very symmetrical, and hence how you can plot the graph. All right, so I encourage you and advise to have whole numbers so that you can easily calculate that. But however, in different like GCSE problems, you might be asked to draw for like not from -3 to 3, but probably from, let's say, -1 to 10. In this case, you need to, with the step of 1, so you need to put all like points, all your x points as an input into your function and just calculate y. So that what is called create or plot the graph from the table. All right, so let's have some footnotes about what sort of curve we have. So the curve with the name of parabola, in this case it opens upwards. So opens upwards means it goes all branches, right, goes upwards. And if you consider what sort of graph, so from, let's say, from like it goes So those branches goes from negative infinity for x. It's like if you just continue calculating, you'll have the graph going on and on top. So actually, but however, if you run from, let's say, in the direction when x is rising, so in positive direction for x, you'll notice that initially parabola is falling down like in this way, right? And then it starts rising after its vertex. So it looks like the vertex is the minimum point. It's here. So that what is called the vertex of the parabola. So it might have some specific coordinates, x vertex and y vertex, and in the next videos I'll definitely show you how to make a vertex form from quadratic equation. So don't worry about that, you'll get it soon. And I also show you the way how you can define the coordinates of that vertex just by completing the square. All right, so make sure you understand that topic because it will be necessary here. All right, so one more time about the features of the graph. There are no negative y values. So, and for this graph, y values, like no matter which point you'll take on the curve, they will have positive y values. However, their x values might be negative and positive. So that's why the curve doesn't go below x-axis, it's completely above, and the vertex is the only point that touches your x-axis. Alright, so the curve is also symmetrical about y-axis. We notice that this value is sort of median, right? On the right side and on the left side, all y values are the same. However, x values are simply inversed in terms of sign. So for example, if you take 1, 2, and 3 values for x, you'll have specific y's that calculated here, 1, 4, and 9. However, for negative part of the x-axis, like -1, -2, -3, you'll have also positive y values and they're the same. So it means on that level, for example, on the chosen level 4, there might be 2 values for x that actually comes 4 from, and that's why your curve is symmetrical. And that's why you can say that y-axis in this case, so the vertical y-axis is simply a line of the symmetry. So that keywords, and that's why in this case this is the line of the symmetry. Later on you might be asked to find an equation of this line. So line of the symmetry. Okay, let's move next. Also, what I want to notice here is also that the vertex is the minimum point for the graph, because below there are no other points. And actually this is what is called turning point, because you see their function is falling up to that point because we're going in the positive direction of x and then start rising. So that's why we have the turn here. So that's why it's also called a turning point. All right, that keywords you need to memorize, or just so simply you need to understand, because for another graph you just need to explore, and might not be symmetrical around y-axis, it might be symmetrical around or along other lines. So it might, the equation might be different. However, you just need to understand what the line of symmetry is. Okay, so let's probably try to explore sort of another function. Now it's not gonna be the simplest form, and we simply start exploring that function. Let's say you have y equals x squared plus 2x, and let's say plus 3. Okay, what do we know about that? So we know that we can simply say that we can arrange xy table for that, and we can start writing about, let's say, I know that the vertex already is going to be -1 because it can be calculated in a specific way. So that's why, but I mean, about you guys who don't know why is it so, just we simply start running our points, our x-coordinates from, let's say, -2, -3 is better. Yeah, let's start from -3, then -2, and then -1, and 0, 1, 2, 3, just somewhere around that vertex coordinates. But actually, later on, you'll understand that to plot the graph, it's the first case, the first step that you need to do is to define the vertex coordinates, the vertex point, because it's easier when you know where the vertex, at least for x coordinates, you need to go around. So you set up like the x coordinates for the vertex, you can like spread around that coordinates, like let's say 3 steps to the right and 3 steps to the left. Because we have -1, we can actually do spreading around -1 to the right side and to the left side. So simply -2, -2, -3, and here in this way 0, 1, 2. So 3 is probably redundant because I want to say that your x vertex should be like sort of median. It should split your set of coordinates into 50%. So from left side you'll have 50% of data, from the right side you also have 50% of data or points, because you want to have your curve to be symmetrical. Okay, so anyway, we just calculate, plug in the values and calculate the resultant. Okay, I'll just use calculator for simplicity, and we'll just simply start doing the following. So we plug -3 and calculate. So -3 squared is 9, then we times 2 is -6, it's going to be 3, and 3 one more time, we'll get 6x as for y value, right? So if we plug -2, let's see what we'll get. We'll get 4, -4 is 0, right? And we'll get 3. And if we plug -1, we'll get -1 squared is just 1, -2, it's -1, and plus 3 will get 2. When we plug 0, we'll get simply 3, and we will get 1, we'll get 6. So it looks like it will repeat the values, right? Okay, let's get 2, we'll get 4, and so 4, and then 8, and then 3. We simply get 12 and 15. All right, so 3, 2, 3, 6. Okay, so that's the basis. Because the vertex is -1, so it looks like y values start repeating itself when you just go over. So for example, you moving from there, you calculated 2 values before -1, that's sort of median, right? Median for data set. And on the right side, you'll get 3 and 6 repeating the previous value, but in mirrored order, all right, like reflected. Okay, so that's the case. And let's try to drop it on Cartesian plane. So I do just the sketch so that you have like brief understanding how it works. All values are positive, so we don't care about negative values. So we set up the origin here. All right, so let's start doing. So -1, 0, 1. Okay, so 0, 1, 2, and we'll get also -1, -2, and that's it. Oh, we have also -3. Okay, so then for -1, we'll have the vertex. That's the minimum point, because our graph definitely have branches outwards and upwards. Okay, so let's see how it works. -1 and 2, we set up 2 here. Then we need to set up for negative, so that's the first point, it's here. So it's sort of vertex point, and then -2 and 3. So we have -2 and 3, that one point, and for 0 you'll also have 3. Okay, That's the vertex of the parabola with coordinates -1 and 2, and your parabola starts coming from that point symmetrically. So it looks like that is the line of symmetry. Now it should always go through -1 because this is the x vertex coordinate. So your line of symmetry always goes through the x vertex coordinates and the vertical, of course. So next one, we have -3 and 6. So let it be 6 here somewhere. And that's -3. And for 1, we also get 6. So 1 is here. And that's another point. Now we just use the green line to smoothly connect all the points. Okay. As you understand there, the smallest step you take for x, in this case we always get a whole number like +1. The step is always +1. That's sort of arithmetic sequence. And in this case we have pretty like not so dense amount of points. So in this case it's like less precise, but it's okay if you're asked to do so. Like in the question, just move with step 1, or you're simply given values for x, so stick to the question and just keep calculating your y values. All right, so that's our parabola, branches outwards. This is the line of symmetry, it's here, so symmetry line. Keep in mind that it always goes through the x vertex point and it's vertical. Okay, and we also have y-intercept here, that value. All right, so next time we'll just be exploring more in depth, not only how to plot, because right now I hope you understand and I hope you like that. We also be going through the general equation of the parabola, and through transformation theory we'll trying to catch the idea what each coefficient A, B, and C responsible for. I mean, we'll be doing that gradually. We start from the simplest form, y = x squared, and then we start like adding different coefficients and try to analyze what the effects it will have on your graph. That's very necessary because after GCSE, you'll get into A-level or IB program, and you need to know that. That's the whole transformation theory will be there. So right now I'm just going to share the ideas, and you also need to know it for IGCSE and GCSE extended here. All right, hope you like that. Just put likes in case you enjoy that video. Maybe that was a bit complicated for most of the students, however I tried to do it like for sort of average, because one student is like, some students are really upgraded and they just want to watch and just to revise some tips. So from there, obviously you guys picked up a lot of useful information. So if you're not like sure about that, try to watch one more time, and actually we'll be moving next to the full exploring of the complete and standard form of the functions. Keep joining.